So the Jacob's ladder we built, um, the electronics one, that's the one we're going to talk about for plasma. So Jacob's ladder is commonly called a climbing arc. A spark forms at the base of two diverging poles, and this spark rises and grows longer until it breaks apart at the top of the poles and starts again at the base. Actually, this spark can be better described as plasma. Plasma is ionized air. Normally, air is an insulator, but with enough voltage, the electrons that are part of the air molecules break away from their atoms. Now the air has positive and negative ions as well as free-moving electrons, just like metal. These hot ions make up the plasma, which heats up the air. The heat from the plasma is one reason it rises up the poles. Because the plasma conducts electricity, the spark can now become much larger as more and more plasma is formed. The Jacob's ladder is a beautiful demonstration of the awesome power inherent to electricity. The picture on the left was taken with a long enough exposure for the spark to rise completely up the poles. The Jacob's ladder uses a 10,000 volt step-up transformer to create its U spark. All this information is gotten from the father-son productions, and the Urals right there. Check it out on the lower left. So here's a plasma globe. The 10,000 volt step-up transformer can be used to create a plasma globe. One wire coming from the transformer is connected to a light bulb so that the electricity will flow into it. The other wire is taped to the top of the bulb with its wire strands spread apart. The electric charge between the inside of the light bulb and its outer surface will create an incredible discharge of plasma inside the light. The display is created when the excited electrons that left the air molecules return to the ions. The electrons lose some energy when they reattach to the ions. They emit this energy as light. The color of the light emitted depends on the type of gas that is being ionized. So here's a plasma finger. So the plasma finger, a dowel pivots with a nail and a wire sticking out of its end. This movable wire gets close enough to a small metal rod to create a spark. Then it can be moved further away, creating a stream of plasma. You can control this plasma stream by moving the dowel. It's a safe and fun way to play with 10,000 volts. So a little words of caution, warning, and danger. High voltage is extremely dangerous. Electric current can burn or even kill you. The voltage is so high it can jump through insulation. The hot plasma stream can burn you. So if you're going to play with plasma, you got to follow some precautions. Keep hands at least 6 inches away from all the parts, except the handle of the wooden dowel, while it's plugged in. Be sure the parts are cool before touching any hot parts. Never touch the plasma globe during operation. Okay, I think we're ready for a quiz. What is plasma? The stuff that makes peanut butter spread? Microwave ovens cook food to plasma. Plasma makes kitty litters smell good. Plasma is the fourth state of matter. If you said it's the fourth state of matter, you're right. How much plasma is there? Less than 1% of the visible universe? Over 99% of the visible universe? Or it's rarer than gold? Plasma is over 99% of the visible universe. That's the correct answer. Handling plasma. It's okay to stick your tongue on plasma. French pastry chefs use plasma on their custard. Keep your hands away from plasma. It's hot. Plasma is so cold that it can freeze water instantly. So, if you said Keep your hands away from plasma. It's hot. That's the right answer. What is Jacob's ladder? It's from the book of Genesis in the Bible. It's a toy that flip-flops on itself. It's a scary movie that makes me afraid of the dark. It's a really fun way to make plasma with 10,000 volts. All of these answers are correct. Plasma globe. Plasma globes get their color from the gas in the globe. The Harlem Globetrotters use these. Light is emitted when the electrons rejoin the ions. They get super hot due to the 10,000 volts. So, if you said that plasma globes get their color from the gas in the globe, that is correct. And light is emitted when the electrons rejoin the ions. Plasma fingers. Not a polite finger to show to an adult. A really fun and safe way to play with 10,000 volts. Can be made for 9-volt batteries. McDonald's uses plasma fingers to cook their sandwiches. The Harlem Globetrotters show this finger to the referee. Okay, if you said it's a really fun and safe way to play with 10,000 volts, you are correct. Any questions? Okay, that's it. I'm going to still talk, but you can blow it off if you want to. There's just there's another little video if you're interested. Further applications of plasma, again, from the Princeton Plasma Physics Laboratory.
One of the exciting things about fusion research, about working with hot plasmas, is that there are many, many applications of these plasmas, both to science and to technology. The science that we're doing helps us understand, for example, the space weather that's generated off of the sun. And the technology we do is connected to many, many areas of technology down here on Earth. Plasmas are used for processing computer chips. About 30% of the steps in making computer chips are done now with plasmas rather than with liquid reagents. Plasmas are a much sharper scalpel, so you can make the narrow features on these chips, and they also generate vastly less waste than liquid reagents. Another interesting application of plasmas is for satellites. Satellites are put in orbit around the Earth up at about 24,000 miles in order to be in geosynchronous orbit, meaning if you put it up over the Isthmus of Panama, you're hoping that it's going to stay there as the Earth rotates. It'll rotate right along with the Earth. You have to have fuel on board that satellite, and it can have a thrust and readjust its position to stay over the Isthmus of Panama. The lifetime of these satellites is set by how much fuel they can hold on board. If you use a plasma as the fuel, if you exhaust from this satellite very energetic plasma, you need much, much less fuel. And some of our best theorists have come up with ways to improve that technology. We think the next generation of communication satellites will use indeed these kinds of plasma thrusters.